Okay. Up here on the board, I have a problem. How, ladies and gentlemen, how would we add these together? Find a common denominator. And what would our common denominator be?
X plus 2.
Okay, so if we were to add these two together, we would multiply this one by x plus 2, right? And this one by x over x. And we'd have x plus 2 over x times x plus 2. Plus 2x over x times x plus 2. And we could add these two together, right? Okay, what we get to do today is work from here to get back to the 1 over x plus 2 over x plus 2. That's our goal. Okay, so we took two fractions and we squished them together. What we're going to do is we're going to take a fraction and we're going to pull it apart. Okay, we're going to decompose it. Partial fraction decomposition is what we're doing. Okay, we're going to take a fraction and we're going to pull it apart. Okay, so today, okay, so today I'm going to show you how to set up the problems, and tomorrow we're going to do all the algebra for it. So today we're just figuring out how to set up the problems. Okay, so this is what we're going to do. The first thing, okay, so partial fraction decomposition is just going in reverse from what we just did. The first thing you're going to need to do is you're going to factor the denominator. Okay. However many factors there are in our denominator, that's how many fractions we're going to break it apart into. Okay, so if we have 3 factors downstairs, we're going to have 3 fractions that we're breaking this apart into. Okay, so knowing that, we're going to write the 3 fractions that we want. Okay, what we're going to do is we're going to put a variable upstairs for each fraction. Okay, so if we have 2 different fractions, all right, that we are breaking this apart into, we're going to put an a in the numerator for one and a b in the numerator for another, and that's what we're going to have to figure out. Okay, now there are a couple stipulations. Okay, if we have repeated factors, then we have to include all the powers of that repeated factor. Okay, and I'll show you what that means when we get to an example. Okay. If you have a quadratic factor, then the numerator has to be linear. Okay. So if we have linear factors, which we're going to have most times, that's what we're going to see. Linear factors, we're just going to have a constant in the numerator. But if we have a quadratic factor, we have to have linear in the numerator. Okay, and that's where we're going to stop today. We will have more, well, not like with notes, but that's where we're going to stop in the process today. Like I have more down here, but we're going to talk about those tomorrow. We're going to practice setting up, and your homework is just setting these up, okay? So let's talk about it. I want to decompose this fraction. Okay, so the first thing we have to do is we have to factor. So Michaela said this is x minus 3 times x plus 2. Okay. So to decompose this fraction, how many fractions are we going to add together? 2, because there are 2 factors in our denominator. So one is going to be x minus something over x minus 3. The other is something over x plus 2. And right now we're going to write A and B. Tomorrow that's what we're going to figure out how to solve for. I told you that these are going to be quick. We're just setting up. How do we figure this out?
Do we leave space to do?
I cannot remember. Let me see if they're the same examples. That's a great question. No, I have different examples. Okay. All right. Next one. So the first thing we have to do is factor our denominator. How many fractions are we going to add together? How many? 2. One with the denominator x plus 2, and one with the denominator x minus 2. Since these are linear factors, we're just going to put an a and a b, and we'll figure out what a and b are tomorrow. Not done. Just be patient. 3 more examples. Okay? These are the easy ones. Don't give me a sigh.
Can we go back?
Yes, we can go back. Yes, sir. Okay. Quick. Okay. So first, we would need to take out an x. Then what? So we have x times x plus 1 squared. Nope, we don't have to do anything to the top. Okay? All right. How many factors do we have in the denominator? 3. So we are going to add 3 fractions together. A over x. Okay. Now, x plus 1 is a linear factor that is repeated. So we need x plus 1. But if I make this an x plus 1, when we try to add these back together, our GCF for our what am I trying to say? Our common denominator would only be x times x plus 1, right? That's not the denominator we want. So if you have a repeated factor, you have to include x plus 1 and x plus 1 squared. Okay? And since these are linear, we're still going to write just constant upstairs. If that was x plus 1 cubed, you'd have x plus 1, x plus 1 squared, and x plus 1 cubed for denominators. Okay, you need all of the powers represented. What does this denominator factor to? how many factors do we have in our denominator?
3.
We have 2 factors. It's degree 3, but there's only 2 factors because we cannot split x squared plus 1 apart. So we're going to have 2 fractions that we're going to add together. One with a denominator of x and one with a denominator of x squared plus 1. Since this denominator is linear, we're just going to put a constant upstairs. But since this denominator is quadratic, we need linear upstairs. Okay. If your denominator is quadratic, you need a linear expression upstairs. So far, so good? Last one. Are you ready? You're thrilled. I know it. Denominator, what is it?
X squared times x squared minus 1. Wait, x minus 1.
You got it, you got it. Okay. Be very careful. How many factors are downstairs?
3.
There are 3. What should go here? What should go here? X squared, and what should go here? Okay, here?
A.
Okay, let's talk about it. This is why I want to talk about this problem. Because x squared, you read off to me as a repeated linear factor, correct? So since this is a repeated linear factor, I know this looks like a quadratic. So did that one. But since it's a repeated linear, we still treat it like a linear. Okay. That's why I wanted to do that one. Okay. Any questions? Your homework. It will take you less than 10 minutes, okay? If you are focused and not distracted. So, if you need to go back and do some linear programming problems again, I would suggest doing so. If not, then you have a nice short assignment tonight. Yay!
I've never had it so hard.
Huh?